Let's solve a word problem involving ratios and differences. The problem states, the difference between two whole numbers is 66. The ratio of the two numbers is 2 to 5. What are the two numbers? Let's understand what we know and organize our information. Let's call the smaller number x and the larger number y. We know their difference is 66, so y minus x equals 66. We also know that the ratio of x to y is 2 to 5. Let's visualize what this ratio means. If we divide the larger number y into 5 equal parts, then the smaller number x would be equal to 2 of those parts. This means that each part represents the same value. Since y minus x equals 66, and y is 5 parts while x is 2 parts, the difference of 66 must represent 3 parts because 5 parts minus 2 parts equals 3 parts. Therefore, each part must be worth 22 because 66 divided by 3 equals 22. Now we can find our two numbers. The smaller number x is 2 parts, so x equals 2 times 22, which is 44. The larger number y is 5 parts, so y equals 5 times 22, which is 110. Let's verify our answer. The difference between 110 and 44 is indeed 66. And if we check the ratio, 44 divided by 110 simplifies to 2 over 5. Therefore, our answer is correct. The two numbers are 44 and 110. Let's solve this word problem step by step. The problem states, the sum of two numbers is 95, and one number exceeds the other by 15. Let's find these two numbers. Let's start by defining our variables. Let's call the smaller number x and the larger number y. Let's visualize what we know. We can represent our two numbers on a number line. The larger number y is 15 more than the smaller number x. Now, let's write our equations based on what we know. First, we know their sum is 95, so x plus y equals 95. Second, y exceeds x by 15, so y equals x plus 15. Let's solve this system of equations using substitution. Since we know y equals x plus 15, let's substitute this into our first equation. This gives us x plus 15 equals 95. Simplifying, we get 2x plus 15 equals 95. Subtracting 15 from both sides, we get 2x equals 80. Finally, dividing both sides by 2, we get x equals 40. Now that we know x equals 40, we can find y. Remember, y equals x plus 15, so y equals 40 plus 15, which equals 55. Let's verify our solution. First, is there some 95? 40 plus 55 equals 95, so yes. Second, does one exceed the other by 15? 55 minus 40 equals 15. So yes again. Therefore, the two numbers are 40 and 55. And that's how we solve a word problem involving sums and differences. Thank you for watching. Let's solve a ratio word problem. Two numbers are in the ratio 5 to 3, and they differ by 18. Let's find these numbers. Let's visualize this with a diagram. If we have two numbers in the ratio 5 to 3, we can represent them as 5 parts and 3 parts. And we know their difference is 18. Let's understand what one part represents. If 5 parts minus 3 parts equals 18, then 2 parts must equal 18. Therefore, 1 part must equal 9. Now, we can find our two numbers. The first number is 5 parts, so multiply 9 by 5 to get 45. The second number is 3 parts, so multiply 9 by 3 to get 27. Let's verify our answer. First, are the numbers in the ratio 5 to 3? 40. 5 divided by 27 equals 5/3. So yes. Second, do they differ by 18? 45 minus 27 equals 18. So yes. Therefore, the two numbers are 45 and 27. To summarize, we solved this by first finding what one part equals, which was 9, and then multiplied that by 5 and 3 to get our two numbers 45 and 27. Let's solve this problem step by step. We need to find 3 consecutive integers that add up to 51. Let's first understand what consecutive integers means. If we call our first number n, then the next number would be n plus 1, and the third number would be n plus 2. Now, we know these 3 numbers add up to 51, so we can write n plus 1 plus n plus 2 equals 51. Let's solve this equation. First, let's combine like terms. We have 3 n's plus 1 plus 2. On the left side, 1 plus 2 is 3, so we have 3n plus 3 equals 51. Now let's subtract 3 from both sides. 3n equals 48. Finally, divide both sides by 3. N equals 16. So if n is 16, then our three consecutive integers are 16, 17, and 18. Let's verify. 16 plus 17 plus 18 equals 51. Therefore, the three consecutive integers that add up to 51 are 16, 17, and 18. Let's solve this problem step by step. We need to find three consecutive multiples of 8 that sum to 888. Let's first understand what consecutive multiples of 8 look like. The multiples of 8 go 8, 16, 24, 32, and so on. Notice that each multiple is 8 more than the previous one. Let's call our first multiple n times 8. Then the second multiple would be n plus 1 times 8, and the third would be n plus 2 times 8. Since we know these three numbers sum to 888, we can write n times 8 plus n plus 1 times 8 plus n plus 2 times 8 equals 888. Let's distribute the 8 in each term. We get 8n plus 8n plus 8 plus 8n plus 16 equals 888. Now let's combine like terms. We have three 8n terms, so that's 24n plus the constants 8 and 16, which is 24. So we get 24n plus 24 equals 888. To solve for n, first subtract 24 from both sides. 24n equals 864. Then divide both sides by 24. N equals 36. Now we can find our three consecutive multiples. The first multiple is 36 times 8, which is 288. The second multiple is 37 times 8, which is 296. And the third multiple is 38 times 8, which is 304. Let's verify our answer. 288 plus 296 plus 304 equals 888. Perfect. We've found our three consecutive multiples of 8. Welcome. Let's solve this linear equation step by step. The equation we need to solve is 2x minus 3 equals x plus 2. To solve this equation, we'll follow these steps. First, get all terms with x on one side of the equation and all other terms on the other side. Then combine like terms. Finally, solve for x. Let's start by subtracting x from both sides of the equation to get all x terms on the left side. When we subtract x from both sides, we get 2x minus 3 equals 2. Now let's combine like terms on the left side. 2x minus x simplifies to x, so we have x minus 3 equals 2. Finally, let's solve for x by adding 3 to both sides of the equation. Adding 3 to both sides gives us x equals 5. Let's verify our solution by plugging x equals 5 back into the original equation. 2 times 5 minus 3 should equal 5 plus 2. Let's see. 2 times 5 is 10. Minus 3 is 7 on the left side. On the right side, 5 plus 2 is 7. 7 equals 7. So our solution is correct. Let's visualize this solution on a number line. The solution x equals 5 represents the point where the expressions 2x minus 3 and x plus 2 are equal. In summary, we solve the equation by getting all x terms on one side, combining like terms, and solving for x. We found that x equals 5, and verified the solution was correct. Welcome. Today we'll solve the linear equation 3x equals 2x plus 18. Let's solve this step by step. Step 1. We need to get all terms with x on one side of the equation and all other terms on the other side. Let's subtract 2x from both sides to get all x terms on the left. When we subtract 2x from both sides, the 2x terms on the right cancel out, and on the left we get 3x minus 2x, which simplifies to just x. Therefore, x equals 18 is our solution. Let's verify this answer by plugging it back into the original equation. Let's substitute x equals 18 into our original equation. 3 times 18 equals 2 times 18 plus 18. Let's calculate. 3 times 18 is 54. On the right side, 2 times 18 is 36 plus 18 equals 54. Since both sides equal 54, our solution is correct. Let's visualize this solution on a number line. Our solution x equals 18 shows where the expressions 3x and 2x plus 18 are equal. Let's also visualize this graphically. We can plot y equals 3x in blue and y equals 2x plus 18 in red. The point where these lines intersect is our solution, the point 18, 54. In summary, we solve the equation 3x equals 2x plus 18 by first subtracting 2x from both sides to isolate x, getting x equals 18 as our solution, and finally verifying our answer by substitution and visualization. The solution x equals 18 represents the point where 3x equals 2x plus 18.